Thank you. Yeah, my name is Zach Howard. I'm from a company called Inata. I've been there for about 3.5 years, and I'm their lead architect of their backend systems. At Inata, we're a platform for retailers to power different digital experiences for their customers. So things like e-commerce, e-flyer, digital loyalty, and mobile. We have a big we use Python at Inata quite extensively. Most of our backend is written in Python. Actually, I'm pretty sure all of it is. But anyways, let's get started. So this talk's called ORM, your ORM. Could be a bit of a misnomer, maybe not exactly that, but I thought it was kind of a funny title that would probably confuse a lot of people. So in this talk, we're going to be talking about a brief introduction to ORMs. Some difficulties that we've encountered when using ORMs in a growing team in a large code base, and then talking a bit about our solution to that problem, an evolution to a solution, and then some key takeaways and trade-offs. This is really about our experience as a company working with an ORM and our attempts to reel it in a little bit after it got a little bit out of hand. ORMs are always a polarizing topic, I find, and what better than to start with a quote from a polarizing person. Love your haters, they're your biggest fans, Kanye West. This is, I don't know, this seems like an apt quote for this kind of talk. We ran into problems with ORMs, so we built a similar abstraction layer. Introduction to ORMs. What is an ORM? It stands for Object-relational mapping. And basically what it is a framework for mapping an object-oriented domain model to a traditional relational database. Most of the time you're not really writing SQL, you're writing code in your comfortable language of choice, and you're doing so through an object-oriented sort of interface. And it's essentially encapsulating the code that's manipulating the data on the relational database. So why use an ORM? They're very object-oriented programming is familiar. A lot of people kind of understand it and pick it up quickly. And I think that's one of the reasons why people like ORMs. It's also conceived sort of from don't repeat yourself principles, which if you think about it, the problem was like we have these objects, now we have a relational database. How do we persist these? And then it's kind of like generalizing over and over again until you have a very general framework for doing that. People like them because they do automatic sort of sanitization of input. You don't have to worry about things like SQL injection and that kind of stuff. They work really well with the MVC pattern, model view controller pattern, and that's something that's really popular in web programming and building user interfaces. And list goes on and on. This talk's not really about why you should use an ORM or not. It's just about our experience using an ORM. Here's some popular Python ORMs. SQL Alchemy, which is what this talk is mostly going to be in context of. That's what we've used at Inata. Some other ones are Django. I've got a little bit of experience with that, and Storm. I've never really used that one before, but I saw that one out there. So, what are some of the difficulties that we faced with the code base where we ended up sort of with ORM objects everywhere? And I'm going to start with a bit about our sudden realization that you're building an e-commerce platform in your startup. I don't know if anyone else has had this problem, but we had originally built our infrastructure on MongoDB. Sort of a decision that was before my time, but you really realized that we actually had very relational data. We needed a sort of transactional database with consistency for things like orders and payments and stuff like that. And then so we migrated to Postgres. And that was a big project. We ended up having to migrate a lot of our business logic because it was sort of built into existing Mongo code base. And we basically went with SQL Alchemy, and SQL Alchemy it was like a really sort of eye-opening thing. It's a super flexible, powerful ORM, and we went a little bit wild on it. What could possibly go wrong? This is a Flask view that, I don't even know how much you can read there, but there's like a SQL alchemy query or series of queries in there that I think, looking at this, you can obviously solve this problem with better design and don't repeat yourself principles and some better abstraction. But as we started doing that, we started running into some more problems, which we can talk a bit about more next. And one of those things is, okay, so you have a bunch of this code and you start wanting to sort of encapsulate it into functions and modules. And one of the first sort of difficult things that we ran into was the problem of sort of session scoping. So I've got this function that does some code on a database session or transaction. And then I'm thinking, what if I want to execute this in a transaction that's owned by my caller? So, why not just pass a session object into every function you write, which will solve that problem. That way you'll have control all the way up and down the stack. So trying to determine, this transaction scope is a difficult problem, and it feels a bit awkward to be doing this a lot. This is a bit of code to sort of illustrate how you can get a bit sidetracked, I think, in terms of how you should be thinking about your code and how the ORM sometimes leads you astray. Here we have a sort of create order function in a sort of e-commerce setting. And you're opening up a transaction, getting user, getting your card, and you're going to create this order object, clear your card, and then add the order to the session so it's persisted. And then you think, okay, well, what if I want to do this in the context of another transaction so that if anything happens, like I want to execute payment, for example, and if anything happens there, I can roll back the whole thing, and I don't have to go and clean up something that I've already committed to the database. So, and I think, adding this session is a bit of a distraction. I think having to think about it that way can be a bit of a distraction. Sometimes the easy thing that you go to. I think a better way to approach it is, and in this case, really what we're interested in here is the business logic that's going on. If you see where we're creating this model and we're summing a total here on the price for each item in the cart, that's really the part that is the interesting business logic that we're doing. And I think, really, when we're sort of socially talking to the database, that should be on a higher level than our business logic. We should be thinking from the outside in. So instead of bringing our session into our business logic, we should be thinking about it as putting our business logic in sort of self-contained functions and then calling that from the outside, doing our I/O from the outside. And that's what this bit of code here does. I still think it makes sense to have a create order function, and you'll see here that actually there's a mistake. We're creating the order object, we're clearing the cart, we're executing the payment, and we're getting the behavior we want, but we haven't basically complected the creation and business logic with the database transaction, which is something I think that's not always intuitive right away when you're working with the ORMs. So this is a subtle difference, but it's powerful. The next one I want to talk about, which is related, is about lazy load associations. I think these things can be really confusing sometimes. For those of you who don't know, lazy load associations are basically when you have an ORM object and you have a relationship to another object, whether it be many to one, many to many, or one to many. And basically, there's two types of way of loading those relationships. One, you load them eagerly, so the associations are loaded on the object when the parent object is loaded. And the other one is lazy loaded, where only the association is only loaded when you want to access it. And this seems like a good idea because, why fetch data that you might not necessarily need? So fetch it right when you want it. And I think this gets confusing because, and here's a little bit of detail about how you might do this in SQL Alchemy. You can basically set up a relationship on for example, user, and the user has one loyalty card that they've got in this case, and it's sort of a many-to-one scenario. But I think this gets can be pretty confusing because you get into dangerous situations where you open up a transaction, you want to fetch this user, but you don't want to keep your transaction open forever, but you want to do something with it. And then in your code later, you end up wanting to access this lazy loaded attribute, but because you're outside of that transaction scope, you get an exception saying we're not. You basically don't have any context with which to communicate to the database. And I think this can be confusing to people, especially in larger code bases. You're not really sure whether you have. It's easier if you could reason about it to say this thing will always be there, or I know it's not always going to be there. Some of the other difficulties that we've faced are business logic built on ORM objects, and this is, tying core business logic that your company has built up and basically coupling that to a library that you've chose, I think is a dangerous concept. If you ever have a problem with we need to scale and we need to switch to another data store, or if we need to, for whatever other reason, change your technology, you basically end up having to rewrite and retest a lot of your core business logic that you could have originally abstracted out. And another one is testability, setting up test fixtures for ORM objects and business logic that acts on ORM objects can be tricky sometimes. I end up having to write quite a bit of boilerplate code. The other one is serialization. It's not always easy to serialize these things because they have a lot of internal state, and changing these objects somehow they have a lot of context in them, especially as it relates to the session that they were created in. And again, you can't just simply farm these things off and then serialize them somewhere. Yeah. So evolution to a solution. So started thinking about this problem. We already went from our MongoDB to Postgres conversion, and we sort of said, we don't want to do that again. We want to isolate that ourselves from that and in the future. So as someone famous once said, why not another level of indirection? Yeah, so let's solve this problem with the best tool that we've got. Put something in between. So this is my fancy architecture diagram. To be improved. Diagrams are always one of my pet peeves, even though I am an architect. It's terrible. So here we have basically our ORM on the left side and our sort of relational side. We have what we call our entity adapter. And this is where we're adapting what we call entities, which are sort of very thin value objects. All our core domain objects, things like products, like users, like the loyalty cards, like categories, all these things. Put a persistence layer in between that and the ORM that's sort of got well-defined services. So no longer should we be able to bring in SQL Alchemy into our view controllers and just go wild and do whatever we want. We should be upfront about our design. We should think about it, and we should make purposeful services that interact with these entities and the ORM on its behalf. And then we have these value objects that we're going to pass from our persistence services to the that's going to be our communication sort of mechanism between our persistence services. The REST APIs, our external integrations, and our internal services. And these kind of become the language and the data which we pass around not only between the database and between our applications, but between each other as well. Design philosophy. So this was our philosophies going into it. We wanted to have thin value objects, with a big focus on immutable data and pure functions for our business logic, just to really isolate ourselves from big changes in the future. I think Python does not have a whole lot of facilities for immutable data, but we actually sort of invented one on top of name tuple. And we'll get into that under the hood in the next slide. But the other thing, one of the other philosophies we really wanted to focus on was pure functions. I think pure functions, for those of you if that don't know what that is, it's functions that don't mutate any outside state. Anything you pass in is not good, like you don't have to worry that this function is going to affect your objects that you're passing in or any other global state outside. So if you can think about, immutable data is data that can't change. Strings are a good example of that. Tuples are a good example of that in Python. You have to create a new instance if you want to see a change on that data. So, and this philosophy was largely inspired by Rich Hickey. If any of you are familiar with him, he's the inventor of a programming language called Clojure, sort of a functional Lisp-like programming language. Anyhow, so the other philosophy was a well-defined service layer on top of our database that is purposeful, that has good separation of concerns, and then our core objects should be easy to serialize because we do a lot of distributed systems in our company, and we pass around a lot of data between different servers, and so that's another key philosophy we wanted to have. So let's look at what we've done to the name tuple under the hood. This is kind of like a little hack we put on top. Basically, we are creating this name, the first line of this function. We are creating a new type name tuple. That's what you get out of that. We put some sort of nice convenience on top of that by allowing us to enforce some defaults or some required things. And then basically we're doing another little bit of conveniences. We have this init function, which doesn't require you to pass in all of the names of the name tuple, which I always found was really annoying. But anyway, so you have this, and now you have this immutable object. It's got a little bit of extra sort of nice convenience on top of it, and this is what we're using now for all of our internal business logic and all of our service-to-service communication. Because it's really easy to serialize name tuples. They have like nice asdict functions that just turn the whole thing into a dictionary, and so it's pretty easy to write serialization functions. Under the hood, this is sort of how you use them. You have a user, entity. You're defining the fields like you would in any other name tuple. Some defaults in this case. Here's a sort of nested. Here's an example of us creating an instance of that, and here you have a nested entity scenario. And then we have this concept of, okay, so here you can see on the third to last line, where when we want to change this object, we want to mutate it, we actually have to create a new instance because this thing is immutable. And then you can see here at the bottom, we've got this, we built this sort of abstraction around in this case, the SQL Alchemy session, and we have a .save function. And in that, there's an adapter layer that's sort of hidden. And I'm going to show you about that next. But it is adapting these entities to models in a way that is, well, let's just go into it. So this is a mix-in that we put on our SQL Alchemy models. And it's basically like a little bit of a nice, sort of enables our classes to easily interface with entities. You can see in this function, update from entity, this is really all it does is it's looking at the common names of the entity and the model and saying these things are probably what we want to update. In the toEntity, it's likewise, you can pass in an entity type and anything with a common attribute name, it can pull out of the model. And then you can always override this in the class in the model that you're working with if you need any extra functionality or any extra logic in there to map these things. So basically we have a set of entities and a set of models, and what I find a lot is we don't always want to build our business logic on relational models. And so this allows us to have a sort of mapping from something that we're that we can work with a bit easier to something that we're going to persist with. Here's an example of a sort of service API function. So you can see here, this is just some SQL Alchemy code, and it's querying this model purchase, and we're fetching them by user IDs. But in this case, we have this sort of two-entity layer. So the idea is, when you're outside of the service layer, you're only interacting with entities. You're passing them into the service layer, and you're getting them back. So in our web service code, you're not seeing from SQL Alchemy import anywhere, which is an important separation of concerns, I think, that we have set up. Okay, so what did we learn? Benefits. So entities have become the foundation of our communication objects for distributed systems. That was actually not the original goal, although one of the original design philosophies was easy to serialize. But this has become a side effect that was really beneficial for us. This is how we are talking. All our internal services are not talking to each other, is with these serialized entities. It's forced us to be more design-minded, so we are more purposeful about our design up front. We're not just going a little bit crazy with our SQL Alchemy queries. Whenever we need a bit more flexibility, we go back to the board, we evaluate what we're trying to do, and we try to implement purposeful services or change the interfaces on existing ones to support those things. I think there's better separation of concerns. I think this layer, has made it easier for new people that are joining our team, and engineers that are not super familiar with ORM technologies to be productive. If you have someone that's really knows about how to build Flask or RESTful APIs, they have a sort of service layer set up with easy to use functions and objects that can get them well on their way. And then we still have the power of SQL Alchemy. It's all under the hood, but it's just not quite as exposed. And this is something in Python, you always have to sort of rein yourself in. You can do anything you want, but we kind of, you have to put discipline on yourself and your team. Make sure you're not abusing these really powerful tools. Trade-offs. So efficiency. Obviously, there's a lot of object instance creations. When you're manipulating these objects, in our case, because they're mutable, there's a lot of new instances created. I think that trade-off is worth it, just because I think it's a lot easier to reason about immutable data and pure functions in your code. And generally, although we are a database-intensive system, we have a lot of caching, and that's where the serialization helps too. A lot of caching layers. The other thing is our adapter layer complexity. Sometimes things don't quite map the way you want them to, and you have to tweak some of that. There's a little good amount of boilerplate code sometimes to adapt your entities to your ORM objects. But once that's out of the way, it becomes very natural to work with. Okay, key takeaways. As your code base and team grows, be wary of using ORM objects all over the place. This is just something that we've found. It gets really complicated sometimes. You're constantly worrying about, you're writing business logic, and you're worrying about what happens if I'm in a weird state with the ORM. And then these are things I don't think you should have to worry about when you're writing day-to-day code. Design purposeful persistent services that hide your relational database schema. So this is something that came up really recently with us. We had this big relational table that started to basically we started to outgrow it in terms of our throughput. The database could not handle it anymore, so we had to put up another service, another cache storage solution in its place. Because we were using entities or these value objects on our code base and our business logic, we didn't have to make any changes other than where we were fetching these things from, which is pretty cool. And then if you can, favor immutable data and pure functions for your core business logic. And I think I've talked a little bit about that enough. But that's it. Thank you very much. Does anyone think I'm crazy?
So we have some time for questions. The mic's here. If we could get anyone with a question to come on down.
So it seems like you've taken one extra abstraction layer on top of SQLAlchemy ORM. I like the abstraction layer a lot up there, and I understand all the griefs that you have with SQLAlchemy ORM. Have you considered just ripping that out and using SQLAlchemy core with your abstraction layer directly on top of that?
Right, and that's a good question. I have considered that, but I think we're in a much better spot right now to do that than we would have been, because we already have. We already have a lot of other services that we have to talk to, and we want to put them in this place, be communicating with this data layer on top. And I think now that we've come from SQLAlchemy objects to this abstraction layer, I think we're in a better spot to be able to actually start changing our implementations. Because at this point, we're using tuples all over the place. Do we really need heavyweight SQLAlchemy objects anymore? And that's something that we're definitely looking at in the future, yeah. Not to say that SQLAlchemy objects are bad, but this is just sort of how we've grown, and I think we've outgrown that a little bit, yeah.
I'm still seeing the session parameter as in the service call.
Yeah.
Why is that?
Well, the idea there is that we are only dealing with the session when we're talking about persistence. So in our entities persistence layer, we are still allowed to use the session. But on the outside, in our calling code, we shouldn't have to worry about that. So I'm not worried, and there's a bit of code that I didn't show you, but we basically also abstracted out a little bit of the session and sort of thinking about that more as a generic connection or connection object to any kind of persistence layer. So we tried to hide this, the actual SQLAlchemy session object from in our calling code, in our web service code, in our Flask code. I'd be happy to show you what that looks like after if you want to see it. Yeah.
And what about you're calling your entities the value objects, right?
Yeah.
Are there is there any agreement when you can change then? It's like in your layers, do your SQLAlchemy return your entity and your service returns this entity to some API view,
yeah.
And then the API view changes some attribute. Is there some sort of organization on top of that?
I mean, the entities are more about internal facing things. So, and that's, we're not serializing our entities to return in our external facing APIs, for example. We're designing those for whatever purpose they are providing, whether it be our front-end applications or whether it be an integration with an external service or retailer. So it's more about the internal use cases, if that answers your question.
Yeah. Thank you.
Hi, thanks for the talk. So this all looked very familiar to me. My team has done something I would say approximately similar, putting a lot of sort of Python functions in between calling code and the ORM access. One of the pain points we've hit with that, one of the reasons I feel kind of mixed on the whole idea, is those functions tend to either be, in some cases, very boring and essentially no ops, right? They're just, you name something and then you immediately do it. There's nothing interesting there. Or on the flip side, they can get very, very complicated and you can start reproducing a lot of SQL's interface in Python function arguments. I was kind of curious if you've hit any of those problems and if you can comment on how you feel or how you approach those.
Yeah, so when we originally set out to do this, for example, it's a lot of times when you're writing something like a Flask controller, you want to grab an entity out of the database and you just want to return that. So do you really need to build a purposeful service for that? And so you want to have some generalization. We do have a bit of a layer that is something like fetch this entity from the database with this ID. We do a little bit of generalization where you can filter on certain attributes and stuff like that. But we don't try to overgeneralize. We're not trying to really solve the problem of like a sort of complex query builder. So yeah, you can go really far with that, but I would say don't go too far. Build more purposeful services. Yeah.
I think that's all the time we have for questions. Let's give Zach a big thanks for this talk.
Thank you.